Hello everyone and welcome to this session. In this session we are going to tackle an important topic which is about the pedestrian detection, histogram of oriented algorithm-based detection. What is HOG, histogram of gradient? It is detecting pedestrian in images. It is an important topic in many applications. Extracting effective features to describe pedestrian is critical in the pedestrian detection. HOG is a feature proposed for describing pedestrian appearance in visible images. We can see here some application of the HOG, and it's like the famous application, and we can find many these applications starting with intelligent video surveillance, human robot interaction, self-driving cars. Okay, let's go through the HOG algorithm. We can start with speaking about the effective extraction. Effective extraction of the human contours is the core aspect of the HOG, and the sharpness of the contours is determined through the gradient of the image intensity or illumination. And finally, it is very important to know that the gradient is a vector indicating where the biggest change is in grayscale is located, and which determine the final T-features vector space. Now let's go through the histogram of oriented gradient and on mathematical part. What do you mean with gradient within an image? And let's assume that f of x is a function representing the whole image, and gxy is a function representing the gradient vector of the f of xy image. And we are going to find two types of gradients, gx of xy, which representing the gradient on the x direction for each single point, x and y, and gy of xy is representing the gradient of the y direction at the point xy for each single point on the picture or on the matrix. And I finally, after finding the gx of xy and gy of xy, I supposed to find the gradient magnitude and the gradient direction. Let's see how to find the magnitude of the gradient. First, find the gx of xy, then take it to the power 2, plus gy of xy and take it to the power 2, and the summation overall under square root. This is the equation of finding the magnitude of the gradient. And to find the direction of the gradient, we can use the formula of arctan of gx of xy over gy of xy, or you can find it using theta of xy, or the direction, equal tan inverse to the gx over gy. We can after that map or the values to the from 0 to 255, which is representing the values of the picture intensities. Pixel with large negative change will be black. We can represent the gradient direction with colors black or white. The pixel which has a large negative change will be black, and the pixel which has a positive change. Positive means from 0 to 1, from small to big, uh, big value of the intensity, which will be representing by white color. Okay, let's see. Here we can find the gradient through this picture, which is a block, which is a black block, and there is white small circle inside the block, the black, and we are going to find the horizontal and the vertical gradient. How to find that? Starting from the left to the right, uh, the black color in the original image representing the intensity equal 0, and the white color intensity equal 1. And going from the left to the right, the gradient value will be positive, which will be representing here, as you can see, in the horizontal gradient in white color. And going from the white color, from the inside the circle to outside the circle, from 0 intensity value to 1 intensity value, is giving the gradient value is negative gradient value, which will be represented by black color. As well, here you can see in the vertical gradient transferring from low value of intensity to the high value of intensity from 0 to 1, representing by positive gradient with white color. And here opposite, when we're going from white to the black, from 1 to 0 value of intensity, the gradient color will be black. This is representing negative value of the gradient. Here in this paper, the HOG describing the texture of the rectangular block. It's not going through pixel by pixel, it's going through blocks. Let's see here, each single pixel, so each block or each zone representing by 8 by 8 pixels zone or size. Why do we use 8 by 8? We can use 2 by 2, 4 by 4, and we use 8 by 8 because this method avoids filtering out useful information. We are going to detect but keep the useful or linked information for the original picture. That's why we are just going to take plugs. We can take 16 by 16, 20 by 20, but in this paper we use 8 by 8 pixels. Let's see how to find the value of, or the gradient. For example, we can see I have x1 and x2, and I have y1 and y2. This is representing, and when this plug, when we zoom in, we can find the value of this, for example, by subtracting x1 minus x2, the value to the power 2, and y1 minus y2 to the power 2, and overall under square root. As we can see here, we can apply this equation to find the value of the gradient in that 8 by 8 block. Okay, let's see how we are going to detect the human. For step number 1, we are going to describe the feature. Step number 2, classification, and finally doing the image processing. About the step number 1, which is about feature description, how the human characteristic will be formed. Using scale invariant feature or transform features, or using edge features or gate characteristics or characteristics of the gradient direction. We have 5 methods of characterization of the human. And let's go to the step number 2, which is classification. We have different types of classifications, and we are just going to mention the support vector machines, and step number 2 or way number 2, which is the cascade classification. Here, which is the most important for us, the step of image processing. Step of image processing contains of global scanning and sub-block processing. What do we mean with global scanning? We are analyzing a real-world object to collect data on its shape or its appearance. This is step number 1, and it is very important step to take the overall or collecting some information about the object, about the human, about the pedestrian, to take some information to use it after on the analyzing. And after that, we are going to use sub-block processing. And as you can see, we can divide a picture into multiple parts and process each part separately based on the inner link. That means every single human picture or every single object picture has a different sub-block processing. For example, if we are going to use the method of 8 by 8 pixel for this, for example, this method for this human, to detect this human, for example, maybe it will coming with this human, and maybe with other pedestrian and with other application, we supposed to exchange the way, for example, using different cells or different way of sub-block processing. That's it, and thank you.